Okay, welcome back. We are going to be talking about the coordinate proofs of quadrilaterals now. Yesterday we talked about the coordinate proofs of triangles. We did a right triangle, and then we did scalene, equilateral, and isosceles triangles. Now we're moving on to quadrilaterals. So let's get started. This is actually going to be a two-part video. The first part, we're going to go through what quadrilaterals are and what their characteristics are. And then in part two, we are going to do a couple of examples and walk through. So the first thing, again, very similar to the triangles, there are two methods that allow us to prove quadrilaterals. The first is slope. This allows you to determine if the lines are parallel or perpendicular. The second is distance. This will allow you to determine which sides are congruent. And yesterday we used the slope formula to determine if lines are parallel or perpendicular. So m is equal to y2 minus y1 over x2 minus x1. We had our distance formula that allowed you to find the distance, which was d is equal to the square root of the quantity of x2 minus x1 squared plus the quantity of y2 minus y1 squared. And if you didn't want to use the distance formula, you could use the Pythagorean theorem, which is a squared plus b squared equals c squared. Excuse me, sorry. So now we need to talk about the characteristics of the quadrilaterals. And we have 6 quadrilaterals that we're going to be talking about. Parallelograms, rhombuses, rectangles, squares, kites, and trapezoids. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel and congruent. So if you're dealing with parallelograms, you're going to have to show that opposite sides are parallel. You're going to have to show that opposite sides are congruent to prove that it's a parallelogram. A rhombus is a parallelogram, so opposite sides parallel and congruent, with 4 congruent sides. So again, since it says it's a parallelogram, these two characteristics go with it. A rectangle is a parallelogram with 4 right angles. So it's a parallelogram, so opposite sides have to be parallel, they have to be congruent, and you have to have 4 right angles. A square is a parallelogram with 4 congruent sides, just like a rhombus, and 4 right angles, just like a rectangle. So now we have those pieces. 4 congruent sides, 4 right angles. Moving on to a kite. A kite is not related to any of these. Remember, parallelograms, rhombuses, rectangles, and squares, they're all in the parallelogram family. So they all share similar characteristics. Moving on to the kite. A kite is just a quadrilateral, so a 4-sided shape with 2 adjacent sides congruent and no opposite sides congruent. So it has to have 2 sides that are congruent and the opposite sides cannot be. A trapezoid, again, quadrilateral, not part of the parallelogram family. So it's just a quadrilateral with exactly 1 pair of opposite sides parallel. Meaning it has only 1 pair of opposite sides parallel. It does not have the other. Okay, so those are, and I'm going to highlight that, these are your characteristics of quadrilaterals. that we're going to be dealing with. So you want to write those down. The last part that we're going to do for part 1 of the video is proving quadrilaterals. So when you're trying to prove that something is a parallelogram, you are going to prove that opposite sides are parallel using slope. You're going to prove that opposite sides are congruent using distance. And again, that could be the distance formula or Pythagorean theorem. For a rhombus, you're going to show that all 4 sides are congruent. You could also show that opposite sides are parallel. Okay? For a rectangle, you're going to show that opposite sides are parallel, and then show there is one right angle. And the way you're going to do that is with slopes. Remember, perpendicular slope. And I'll put the perpendicular symbol down there. For a square, you're going to show it as a rhombus. Because remember, a rhombus has 4 congruent sides. A square has 4 congruent sides. So show that it's a rhombus, and then show there is one right angle as well. Again, perpendicular slopes. Because as soon as you have 4 congruent sides and you have one right angle, all the other angles have to be 90 degrees. The last 2 that we're going to talk about is a kite. The kite, you have to have 1 pair of adjacent sides congruent. Again, you're going to use distance formula there, but not all 4 sides congruent. Because if all 4 sides were congruent, it would not be a kite, it would be a rhombus or a square. The last one that we're going to talk about is a trapezoid. And you have to show 1 pair of sides parallel. Again, we would use slope. And the other sides shown to not be parallel. Very important when you're proving something as an image or a shape. Sometimes you prove that it is. Sometimes you prove that it is not. Okay? And again, these are things that you do when you're proving quadrilaterals. This is how you prove quadrilaterals. Okay, I'm going to stop this video. Make sure you copy all this information down. You understand it and you're able to use it. That's the most important thing. Don't just copy down and not understand what you're writing. Because if you ask me to come around and ask me for help, I'm going to tell you to pull these notes out and this information and use it. Get ready for part 2.